You are cruising northbound on I-80, somewhere past the Nevada salt flats, 60,000 pounds of freight behind you, fuel costs already eating your margin alive, and you glance down at your instrument cluster expecting nothing but highway, and suddenly the amber glow of a warning light you have been dreading your entire career burns itself into your retinas like a brand. DEF system malfunction. Your stomach drops straight through the floorboards. You know exactly what this means because you have heard it from every other driver at the fuel islands, at the scale houses, at the truck stops at 2 in the morning over bad coffee. You know the countdown has already started. The computer is already doing the math against you. 100 miles. That is all the runway you have before your engine management system initiates a forced derate that buries your top speed at 5 miles per hour, turning your $70,000 commercial rig into a rolling road hazard on the shoulder of an interstate where every passing car is doing 80. You are looking at missed delivery windows. You are looking at a broker phone call you do not want to make. You are looking at a tow to the nearest authorized service center, where a service writer in a clean shirt who has never turned a wrench in his life is going to hand you a diagnostic estimate with a number on it that starts with 3 and ends with 3 zeros. $3,000. To fix a clogged injector tip smaller than your thumbnail? And while you are sitting in that waiting room watching your revenue evaporate by the hour, there are veteran fleet mechanics in independent shops across this country who already know the real solution, and it does not come from an emissions parts counter. It comes from a hardware store aisle that has nothing to do with trucks, and it costs less than your last cup of coffee at the Pilot. Stay right here, because what you are about to learn is the maintenance knowledge that the dealership service department is financially motivated to make sure you never find. The DEF additive industry is a multi-million-dollar machine built on one specific piece of ignorance they need you to maintain, which is the belief that fighting urea crystal buildup requires a specialty chemical product sold exclusively through their distribution network. Walk into any major truck stop chain in this country and you will find a rack of small bottles with aggressive branding, diesel-specific labeling, words like premium and professional and maximum strength printed in fonts designed to communicate authority, and price tags between $25 and $40 for quantities so small you could fit them in your shirt pocket. These products are marketed as DEF system protectors, anti-crystallizers, injector system treatments. Drivers buy them by the millions because the alternative appears to be a catastrophic repair bill and a broken delivery schedule. The products sell because the fear is real. But here is what the label does not tell you and what the manufacturer is counting on you never investigating. These retail formulas are predominantly surfactant blends with wetting agent chemistry at concentrations that prevent crystal adhesion in a laboratory test environment, meaning a clean injector tip that has never seen field conditions. They are engineered to stop future crystallization on a surface that is already clean. They are completely chemically incapable of dissolving an active crystalline blockage that has already formed, hardened, and triggered a fault code. You are buying a wax coat for a wall that has already been bricked shut. The actual solution is not on that truck stop rack. It is in the masonry and concrete cleaning aisle of any hardware store in America, and it costs $5. Warm distilled water. That is the opening piece of the protocol. But the mechanism requires the second element, which is controlled temperature elevation to a specific working range, and the third element, a mild alkaline agent that anyone with a box of baking soda already has in their possession. Before the trucking industry became a compliance management exercise dressed up as a logistics business, long-haul mechanics developed field protocols for keeping equipment running without access to dealer infrastructure because there was no dealer infrastructure. There was the road, there was the problem, and there was the solution you could execute with what you carried or what you could buy within 5 miles of wherever you broke down. The warm alkaline flush is exactly that kind of solution. It is not controversial in the chemistry. It is controversial only to the industry that profits from you not knowing it. Here is what is actually happening inside your DEF system when that warning light comes on, and understanding this is the difference between a driver who owns their maintenance situation and a driver who gets owned by it. Diesel exhaust fluid is a precisely formulated aqueous solution of 32.5% high-purity urea in distilled water. That ratio is not arbitrary. It is the eutectic concentration, meaning it is the specific mixture that provides the lowest possible freezing point for the solution while maintaining the chemical activity required for selective catalytic reduction to function at emissions compliance levels. The system works by dosing precise quantities of DEF into the hot exhaust stream ahead of the SCR catalyst, where heat breaks the urea down into ammonia, and the ammonia reacts with nitrogen oxides across the catalyst surface, converting them into nitrogen and water vapor. Clean exhaust? In theory. The engineering problem is that the dosing injector operates in a thermally dynamic environment where exhaust temperatures fluctuate dramatically between highway load conditions and idle, cold start, and shutdown cycles. During those cool down phases, the water fraction of any residual DEF at the injector tip evaporates faster than the urea fraction can remain in solution. What gets left behind is solid urea, and solid urea, in the presence of heat and time, undergoes a transformation process that produces a crystalline deposit with a structure dense enough to partially or fully block the injector orifice. This is not a manufacturing defect. This is chemistry behaving exactly as chemistry behaves, and the system designers know it happens, which is why they specified injector purge cycles and heating elements to manage it. The problem is that those engineering controls degrade over time, that real-world operating conditions routinely exceed their design parameters, and that any driver running shorter routes with frequent cold starts is accelerating the crystallization rate significantly. The deposit you are fighting is not simple dried urea. It is a compacted, partially converted crystalline matrix that commercial surfactant products cannot penetrate at the molecular level. What dissolves it is not an exotic chemical, it is solubility physics. Urea has extremely high water solubility, documented at approximately 1,080 grams per liter at room temperature and increasing dramatically with temperature elevation. When you raise the temperature of distilled water into the range of 60 to 70 degrees Celsius, its capacity to dissolve urea crystal structures increases to the point where even compacted crystalline deposits at an injector tip will break down and go into solution within a matter of minutes. Adding a mild alkaline agent shifts the pH of the solution slightly above neutral, which further disrupts the crystalline lattice structure without introducing corrosive chemistry that would attack the metal components of the injector body. This is not a theoretical mechanism. This is the physical chemistry of urea dissolution, and it is what the retail additive products are deliberately formulated to obscure, because a driver who understands solubility does not need a $30 bottle of branded surfactant. Now let us talk about the $30 product sitting on that truck stop shelf and exactly what you are actually paying for when you buy it. Independent analysis of commercial DEF anti-crystallizer products consistently reveals formulations built around alkyl polyglucoside surfactants or similar non-ionic wetting agents in dilute aqueous carrier at concentrations between 2 and 8% active ingredient. These compounds reduce the surface tension of water, which improves the wettability of surfaces and can discourage crystal adhesion in ideal conditions. In a controlled laboratory test where a clean injector tip is treated preventatively, these products may show measurable reduction in crystal formation over an extended test period. In the field, on a truck that has already thrown a fault code because the injector is blocked by a compacted crystalline deposit, these surfactants have no meaningful penetration capability into the dense crystal structure. They sit on the surface. They do not dissolve the blockage. The service writer at the dealership knows this. The counter person at the parts house knows this. The product marketing team at the additive company certainly knows this. You are being sold a product positioned as a system solution that is technically formulated as a preventative coating, and the positioning is deliberate because a preventative product creates recurring purchase cycles. You buy it, it does not fix the active blockage, you conclude you need professional service, you pay the $3,000, and then you start buying the preventative product again afterwards so it never happens again. That is not a maintenance solution, that is a revenue loop, and you are the asset being harvested. Here is the exact protocol that gets your injector clean and your truck back on the road without a service appointment. Work in a well-ventilated area, preferably with the truck shut down and exhaust temperatures fully cooled. Gather your materials before you start. a bottle of distilled water, a box of baking soda, a kitchen thermometer, or any digital probe thermometer accurate to within a few degrees, a heat-safe plastic or glass container large enough to submerge the tip of the dosing injector, a soft bristle brush that will not scratch metal surfaces, clean lint-free cloths, and your basic hand protection. Step 1 is to locate your DEF dosing injector on the exhaust pipe, typically positioned upstream of the SCR catalyst housing. The injector is retained by a single bolt or clamp fitting and has an electrical connector attached to the solenoid body. Before you touch anything, disconnect the electrical connector first and secure it away from the work area so it cannot contact any liquid during the procedure. Step 2 is to heat your distilled water to 65 degrees Celsius. Do not exceed 70 degrees. You are not trying to boil the water. You are targeting a specific thermal window that maximizes urea solubility without creating steam that could drive deposits further into the orifice or create thermal stress on the injector components. Use your thermometer and take your time. Step 3 is to add a quarter teaspoon of baking soda to approximately 2 cups of the heated distilled water and stir until fully dissolved. This produces a mild alkaline solution with a pH in the range of 8 to 9, sufficient to assist crystal dissolution without introducing chemistry that will harm the stainless steel or aluminum components of the injector. Step 4 is to remove the dosing injector from the exhaust pipe by unbolting the retaining fitting. Move carefully. The injector body will be warm even on a cooled system. Place the injector on a clean cloth and visually inspect the tip. You will likely see the white crystalline buildup clearly, ranging from a light powder coat to a dense white crust, depending on how long the blockage has been developing. Step 5 is to submerge only the metal tip of the injector, below the solenoid body and well away from the electrical connector port, into the warm alkaline distilled water solution. Set a timer for 5 minutes. You will observe the crystal deposit beginning to dissolve as the warm solution penetrates the crystalline structure and pulls the urea back into aqueous solution. For heavy deposits, a very gentle pass with the soft bristle brush after the initial soak will clear remaining material without scratching the orifice surface. Step 6 is to remove the injector from the solution. Rinse the tip thoroughly with fresh distilled water at room temperature and dry it completely with a lint-free cloth before reinstallation. The critical warning for this entire procedure is this, and it applies absolutely without exception. Never allow any solution, warm water, alkaline or otherwise, to contact the electrical connector pins on the injector solenoid. Moisture intrusion into the connector will cause solenoid circuit faults that present as DEF system errors completely unrelated to crystallization and will send you down a diagnostic path looking for a problem that you created during the fix. Before you reinstall the injector, verify the connector is bone dry. If there is any question about moisture, give it additional time. A 20-minute wait costs you nothing. A solenoid fault code costs you a diagnostic fee and potentially a solenoid replacement. The second absolute boundary in this procedure is that nothing from this protocol enters your DEF storage tank. The warm alkaline solution is formulated specifically for external injector tip cleaning. Your DEF tank requires the precise 32.5% urea solution and nothing else. Any contamination of the tank chemistry will trigger a fluid quality fault at the DEF quality sensor, which reads the urea concentration directly, and a fluid quality fault is a separate and more serious code path that can result in an engine derate independent of the physical blockage you were originally addressing. Keep the tank sealed, keep the cap on. The procedure is entirely external to the tank and the supply lines. Once the injector is reinstalled, the connector is reattached and verified secure, and you have confirmed everything is torqued to spec. Clear your fault codes with a scan tool or by cycling the ignition through the OEM-specified reset procedure for your engine platform, and let the system run a self-check cycle before you pull back onto the highway. The contrast you need to hold in your mind right now is this. On one side of the scale, you have a $3,000 service appointment, a tow bill if you are already in derate, lost delivery revenue measured in hundreds of dollars per hour of downtime, a multi-day wait for a service bay at a dealership that books weeks out, and a $30 additive bottle from the truck stop rack that will do nothing to the blockage already sitting in your injector. On the other side of the scale, you have distilled water, baking soda, a thermometer, and 2 hours of your own time. The chemistry that dissolves the blockage is not proprietary, it is not patented, it is not available exclusively through a commercial distribution network. It is physics and it belongs to you. Every independent owner operator in this country who is fighting emissions compliance codes with nothing but a repair order and a prayer deserves to know that the solution to a crystallized DEF injector is sitting in their kitchen, cabinet, and their nearest grocery store, not in a dealership parts department. The trucking industry has spent 15 years building a regulatory and commercial infrastructure around diesel emissions compliance that has systematically transferred money from working drivers to equipment manufacturers, emissions, system suppliers, and authorized service networks. The DEF system, as implemented, is not designed for the operational reality of independent trucking. The crystallization problem is predictable, it is endemic, and the commercial ecosystem that surrounds it is not oriented toward solving it permanently. It is oriented toward managing it expensively on a recurring basis. Knowing the actual chemistry of urea solubility does not make you a rogue operator. It makes you a driver who understands his own equipment. Share this immediately with every driver in your network, every fleet owner you know who is bleeding money on emissions, repairs, and every independent operator who is one bad DEF code away from a delivery contract they cannot fulfill. The knowledge in this video is the difference between a truck that runs and a truck that sits, and sitting costs you everything. Hit subscribe and stay connected, because there is an entire category of dealership-dependent maintenance costs sitting on your truck right now that have a $5 solution you have never been told about, and we are just getting started.